Okay. Hey, here we go. Okay, let's walk through the problems that I want to cover today. One of the questions that you guys had yesterday was something like this. This is one of my first questions I want to make sure that you know how to do. It was something like that where I had multiple letters. This is not the exact question, obviously. Now, the idea is that you had to figure out which rung of that Pascal's triangle that you're on. I'm on the degree 3 rung. Okay, so Pascal's triangle I'm not going to put up here again, but here's the idea. This is the rung that I'm on. This is degree 3, degree 2, degree 1, degree 0. This is the rung that I'm on this particular problem. Remember, the first rung is degree 0. Keep that in mind. I think I have that on the board yesterday. Now, the rung I'm on is this one, so when I write my numbers out, I'm going to spread them out like I always do. So 1, 3, 3, and a 1. I put parentheses behind each one. Okay, everyone knows the setup. Temporarily, they have plus signs. These might change as we go through the problem. Okay, so this is the part that I want to make sure that you understand. Because I don't know if the problem was like number 29 or something. It was one of those where it was a Pascal's triangle where it had like multiple letters in it. Okay, so here's how it works. This is the first item. This is the second item. That's how I think of it in my head. I separate them. So it's going to be x cubed y, and we're taking that times a negative 2, right? You always have to multiply those two parts in each parenthesis. So x cubed y times a negative 2, x cubed y times a negative 2, x cubed y times a negative 2. Okay, so those are my parts. Now, the thing is, we have to do the power idea. And this is the part that people are getting confused on. How do you put a power on something that already has powers? So the trick is, it's a law of exponent, right? It's just those laws where if you put powers on powers, you multiply them together. So when I go through the power rule, my biggest degree is 3. I'm going to put a 3 on this and a 0 on the negative 2. Each of these items, because there's 2 letters, they're each going to get the power of 3. So if there's already power sitting there, you just multiply it on there. The next group is going to be 2 and a 1, because again, the one power is counting down, the other one's counting up. Then it goes 1, 2, and 0, 3. Okay, so let's walk through what would happen as we did that power, right? Now, here's my question. Does everyone understand how the powers count down and how the other ones count up? Everyone feels comfortable with that situation? I know that there was one problem, I think it was actually this one, it just had a power of 2 here. And I know some people just want to FOIL it, they just want to write the 2 parentheses and FOIL. I understand, I want you to get practice on the easy ones. Try this stuff out for the easy problems. So, here's where we're at. We're going to multiply the powers, the power of 3's on this. So what we're going to have, we have obviously the 1 up front, but x to the power of 3 to the power of 3 is x to the 9. You actually just multiply the 2 powers together. The y, it's y to the first. We're going to take that times 3, so it's y to the 3rd power. And then for the negative 2 to the 0 power is just 1. It's not a negative 1. I know some people were typing this in their calculator, and it kept telling them this. It's wrong because you forgot to put a parenthesis around it. So what your calculator was actually doing is it was calculating 2 to the 0 and then keeping the negative sign out front. It didn't know you were doing a negative 2 to the power of 0. So that was a common mistake people were making yesterday. So anything to the power of 0 cancels out. It makes a 1. Next one, when I put this to the power of 2, okay, you just multiply the power of 2 on both of these. So it's x to the power of 6, because 3 times 2, and the y to the power of 2, because it's 1 times 2. And then negative 2 to the first power is a negative 2. Does that make sense for that second item? Now again, this is not your exact problem, it's close. Next category, I have a 3 up front. I have x to the 3rd power, and I'm going to take it times 1, which is x to the 3rd, and then y to the 1st power times 1 is y to the 1st. You just multiply the powers. And then negative 2 squared is positive 4. Okay? The last number, I have a 1 out front. X to the 3rd, y, all to the power of 0 is just a 1. The variables cancel out. Negative 2 to the 3rd power is a negative 8. Negative 2 times negative 2 times negative 2. And now we can get to our final answer. Is there any questions with how it got to this point? Like my number systems, how the variables are working? It was something that I forgot to talk about it yesterday because we were doing problems where I was always doing one letter, but this one had two, and I thought we'd better talk about it today. I don't know what problem it was. I don't know if it was it 68? Okay, now the final answer, this would be 1x to the 9, y to the third. This would be a negative 6x to the 6, y to the second. This would be a 12x to the third y, and this would be a negative 8 to the back. So there you go. Most people know how to do that from that point on, but it's just getting those original powers. Questions, comments, concerns about any of the example I've done so far? Now, here's my question. Do you want me to finish it, or should I just move to the next problem?
Just move to the next problem.
What was that?
Next problem.
Next problem, okay. Moving on. Okay, now, the next problem. The next problem we're going to do is the brand new stuff. This is the stuff I'm adding to the assignment today. I hinted at it the other day, and I thought we'd better discuss it. They're going to give you shapes, and they're going to want to know the area of the shaded part. So I'm going to shade in a part of this box here. Okay, so they want you to find the area of the shaded part. So that means you have to take out a certain piece out of it. It's like a donut, a square donut. And so for this shape, you have to have the dimensions for everything you need. So let's say that this was an x plus 2. This was a 3 plus x. The inside, let's say this was an x, and this dimension going this way was x minus 1.
Why don't they just give us feet? They do so much.
Yeah, so, yeah. Well, that's the idea of what we're getting to. Now, we have all the dimensions we need. I have the dimensions of the full deck here. I have the dimensions of the pool in the middle. And we are going to subtract them from each other.
It's a massive deck.
So the idea is that we're going to multiply the outside terms. Because how you find area, it's length times width, right? So I'm multiplying these two terms together. So I'm going to have the x plus 2 times the the 3 plus x.
This is finding out the what?
This is the area of the donut, basically, without the center in it. So, the patio, the deck, right? All right. Now,
We've already been.
okay. So we multiply these two terms together. Now, what this would do if I multiply these together, that would give me the area of the entire rectangle. But what I have to do now is I have to subtract the donut piece in the middle, the donut hole, right? So I have to subtract this little pool out of the middle. So the dimensions of the pool, it's length times width again. So that's the x and the x minus 1. So this is the pool, and this is the patio. So you're taking the entire patio and you're subtracting the pool out. That'll give you the area of like what's left. Cool. Does that make sense?
Yeah.
Okay, that's what you're doing on these problems. I think you have 3 of these that you're going to have. They're easy dimensions. I'll put a different one up here in a second. I'm not going to finish the next one, but I'll show you the different pictures they're going to give you. But to finish this problem, you FOIL the first 2 out. So if I FOIL this out, I'm going to do this really quick. First outer and last, I get x squared plus 5x plus 6. That's going in descending order. Sorry, I just did it really fast in my head. Then the item on the other side, if I distribute this x to both parts, I have x squared minus 1x. And that's when I distributed the x. Now, the last thing I have to do here, before I move on, I have to distribute the negative sign into that parenthesis. Anytime you subtract a polynomial, you have to distribute this negative sign into the back part. You're subtracting each item separately. So what you're going to get when you do this, you're going to get a negative x squared plus 1x back there. Because the negative sign goes to each part. Okay, now, before I move on, I know I'm going really fast. Is there any questions with how I came up with some of these numbers? Like the first outer and last idea?
Is that a question or just like
That's my brain.
Okay. The x squares cancel out because one's a positive, one's a negative, so those are gone. The 5x and the 1x make 6x, and then that positive 6 is by itself. So there you go, there's your final answer. This is the answer I'm looking for. It'll be a polynomial in the end. It's not going to be some magical number. It's just a polynomial. You're not solving anything. Don't set it equal to 0 or anything like that. That's the answer I'm looking for. Questions? Okay. Second type of problem. Now, I'm not going to finish this next one. I just want to show you the different styles of pictures that they give you. This next problem is the same type. They just move the donut hole to like the outside. So here's the picture that's in question that they give you. And they give you that this, let's say this is 2x plus 1. This is a 5 plus x. This is a 2x. And this is a 4 plus x. Okay. So here's the idea. How you actually do this. There's two ways to do it. You could find the dimensions of these parts here separately, like find this dimension, so that way you can find this area and take it from the whole picture. So you find the area in the large square, and then you subtract this whole piece out. The second way to do it is to find the area of this room by itself, and you add it to this room by itself. So there's like two separate ways of thinking about this problem. I don't know which camp you're in. I don't know how you see that problem. For me personally, when I do this problem, if I was doing it on paper, usually when I do this problem, I think of like this room, and then I add this room to it. Like that's how I see it. It doesn't matter. It's the same problem. If you like to find the dimensions of this room and subtract it out of the entire picture, I can see that too. Now, I'll give you guys the option. Do you want me to do the subtraction where you subtract the box out, or do you want me to add the two rooms together?
Can you do both?
I can do both. Okay, let's do both. Okay, I'll do the first one. So the first one I'm going to do, I'm going to add the two rooms together. So add the two dimensions together, find my answer. So this box over here is probably the easier box out of the two, the room, because I already have the length and I have the width of it. So to find this room, I'm taking the 4 plus x, and I'm taking it times the 2x plus 1. Okay, that's the area of that room. That's easy, length times width. The other room, this room, is actually the more difficult one, because I don't know one of the dimensions. I know the width of it, which is the 2x, but I don't know the other dimension. So to find the other dimension, to find this length here, what you do is you subtract these two from each other. I just subtract these. So the reason why is this is the longer stick, this is the shorter stick. I would just subtract these from each other, and that will give me the difference between them. Because I take the whole stick and I subtract that piece, it'll be this piece left over. So x plus 5, I'm going to subtract the 4 plus x. So if I subtract these two from each other, the long stick minus the short, that'll give me this question mark right here. Well, if I distribute the negative sign, minus 4 minus x, what you're going to figure out, in common sense tells you this, the x cancels out, the 5 minus 4 turns out to be a 1, that's your dimension right here, it's a 1. It's literally like 1 foot long. And that 1 goes right here. Again, how I did that. I'm taking the long stick, subtracting the shorter piece to get what this difference was. So when I distribute the negative sign, when I'm subtracting big minus small, distribute the negative sign, the x is canceled, and 5 minus 4 is literally 1. So now, the final area, what you'd have to do on this problem, multiply these two pieces together, multiply these two things together, which is really easy, and then you add the two rooms together. So here's the math that I would do. I'm multiplying those two parts, and I'm going to add the 2x times the 1.
And that gets you that area?
That gives me the entire area of the entire room.
Oh.
So 2 easy chunks, but you have to find each piece separately, right? Okay, does that make sense for the first type? Now you can do that, you can FOIL this together. This is just a 2x, so that's kind of easy. But when you FOIL that together, you add the 2x and you're done. The second way of doing it is to find the two dimensions up here, and this is the one that some people want to see as well. This is the second way, I'll put it over here. What you do to find this next part is you take the entire room, and I'm going to subtract this piece out. So the entire room's dimension is the 2x plus 1 and the 5 plus x. That's the entire room that's doing this entire border.
Why don't you just find the other wall with the same?
Yeah, we're gonna do that as well. So here's what we have. The entire room is the 2x plus 1 times the 5 plus x. Okay, that's the entire room. I'm gonna find the dimensions of this little piece right here, calculate what this thing is, and subtract it off the back. Now, this dimension, how I get this piece right here, because I already know this one's a 1. That's a 1 right here. How I get this dimension, I take this piece right here, and I subtract this 2x right here. Because if I subtract the long stick minus this, that'll give me this length right here. That'll be this missing piece. Well, what's 2x plus 1 minus a 2x? 1. This is a 1. And that should make sense. 2x plus 1 makes the entire wall going down. So that's a 1. So if I multiply these two things together, 1 times 1, that'll be the dimension of this room. So that room is like 1 by 1, right? And I'm going to subtract that piece off. 1 times 1 is a 1. Boil the first two parts together, and you can actually subtract it.
You want to suck?
All right, last one we have. This is my last problem of the day. Okay, this one you have to think of it like a Jenga board, like you're playing Jenga.
Is that the one that you pulled the deal out?
Yeah. So,
I don't understand how that was never.
Alright, quit playing with my mind.
okay, so we got a box, right? We're gonna subtract a piece out of it. So I'm gonna make a little piece that we took out maybe out of the top of the Jenga board.
Why are you not an architect?
Yeah, that's a heck of
That is actually pretty good, I'm not gonna
a, that's a
lie.
heck of a drawing right there.
So it's like a horseshoe, okay?
But like,
What the?
Okay, so I got my little horseshoe piece. I'm taking the piece out of the top, that little like stick. Okay, so here's the idea. How you actually do this, how you do this problem or how you attempt it is you have to find the dimensions of the entire like brick. The entire brick. Well, a brick's volume is like height times, depth times length. So the height of this object is x plus 2. The depth, let's say the depth is 2x, and the width here, let's say, is 3x minus 1. That's the entire length. So length, depth, height. Multiply those together. That'll be the volume of the entire chunk. So 3x minus 1, 2x, and an x plus 2. We're going to multiply those together. You just do 2 parentheses at a time, and then just FOIL it to the next one.
Okay.
I've had a lot. Pause.
Still on the first one.
Okay. You're fine. Take your time. Don't start crying again.
I almost started crying this morning, but I'm like, my makeup's doing like, he go like this.
I can't handle the.
That's the only part
I
I
can't handle all the emotions.
go like these. Can you draw the box on my
We're doing really fast.
Oh, shucks.
Did
That's the only thing.
No.
Okay, there's your box.
Okay.
And then chunk over. Chunk. And we're gonna erase. There.
And then you angle it.
There. This way.
This way.
I took art and like.
Are you available on this week?
I'm available all of this. Okay, so here's what we have. We have my little horseshoe. Now, we have the 3 dimensions. We have to multiply those 3 together. Now, for the little Jenga piece that's missing, let's say that the width here is a x plus 1. That's the little width. The height of it, let's say, is just x. And what's the dimension of the depth going to the back? 2x. It's the same dimension as the depth here, because the piece has to be the same length. So that's why the depth going to the back. So the actual 3-dimensional piece here is x plus 1 times x times a 2x. You multiply those three dimensions together, and that'll be the little Jenga piece that's missing. And then what you do is, after you find this answer, and you find this answer, you subtract them from each other. Length with height, right? Length with height.
What one do you oh,
Always take the big chunk, the big brick, and subtract the little piece out.
okay.
But again, it's length with height. Right?
How did I make a picture of that?
Okay, homework that I'm adding. Okay, here's the homework that I'm adding to your homework. Now, if you want, you could separate these on 2 different pages. I'm totally fine with that. Because this page, the page 53 is due tomorrow. Now, if you're really struggling with this stuff, put it on a separate page and I'll take it on Friday if you want to do it that way. That way you have an extra day to work on it. Okay? So, this page is 55 still, but we're doing 93 through 96 and 107 to 109.
Is it on page 55 or 50?
55, that's where these problems are found. It's the same assignment, we're just adding more to it. Yeah, so I said, I know that 53 is due tomorrow. So if you want to turn in the 53 stuff tomorrow, that's fine. This, if you want to put on a separate sheet of paper, you can turn in Friday. Some people just add it to the back, those turn it in all at once, I'm fine with that. But I'll make this due Friday if you want, but 53 is due tomorrow.
I need
You're doing really well. So now just draw this line go from here to there. Draw this line go diagonal.
Can we watch that?
And then the next one just draw from there. Yeah. There you go. I think we're just doing
No, we got the big old
we're factoring.
I tried to ACC.
Reviewing factoring.
No, it's okay. I paid almost $200 for my I was over like
We better live for this year.
I'm pregnant.
I think we should have.
You're in the back. Isaac, this is even worse.
My next one out.
I like taking my
He's got
I would sign up for the only club that had like holes like that. I did that in class. I didn't do it. And then I was like, okay, I'll go do it. I mean, just to see if you get him down and he says, no, they have so many girls like that color in their hair like grew out.
Okay, never get that extra assignment right up here. That one, if you want to turn Friday, fine. But this 53 is due tomorrow.
That would actually be fun.
We'll go over one of those again.
When I got signed up with that, just like, yeah, no. I kind of saw it.
This one?
So we need different.
Through